students, I welcome you all for another video session on Vhdl code for JK flip-flop. Dear students, we have already seen the Vhdl code for SR flip-flop and D flip-flop. So, same procedure is being followed for Vhdl code for JK flip-flop. Okay. So, we will be we will be writing the code in the behavioral model. Okay. So, as I've told, to start up with any VHDL coding for any electronics equipment, you have to know the basic operation of that particular equipment, right? So, here we are going to take our JK flip-flop. So, let me write the inputs for you all. So, we know that flip-flops are not working or will not work without a clock, right? So, we are very much aware of it, and we have the inputs as J and we have the inputs as K, and also we have reset. Let me write this here, reset, and we have an output. Okay. So another thing which we require to write the VHDL code is our truth table of JK flip-flop. So writing the truth table, so let me write the present state and my J and K inputs and my output. So taking my present state to be as Q, so let me write the inputs. So when J is 0 and K is 0, we get the output as Q. When J is 0 and K is 1, we get the output as 0. When J is 1 and K is 0, we get the output as 1. And for the last case, when J is 1 and K is 1, we get the complement of the present state, right? So students, we are very much aware of, the inputs. When J and K are zeros, whatever is the present state will be our output. When J is 0 and K is 1, we get 0. When J is 1 and K is 0, we get a 1. And when both J and K is 1, we get a complement of the present state, right? So students, this is the crucial part for us to write the Verilog code, the VHDL code for the JK flip-flop. Okay. So here we'll be writing the coding considering in the asynchronous reset mode. Okay, asynchronous reset mode. So here we consider this. That means here our reset is not dependent on clock. Reset is not dependent on clock. Okay, so this condition is what we are using or we are referring to while writing the code. So let's see the code of JK flip-flop. So let us start with the library. So you have library IEEE use IEEE.std.logic1164.all. So entity, let me write the component as test JKS. So students, let us declare the inputs. So within the port, I declare the inputs as JK clock reset. Okay, so these are my inputs. So it is my inputs. So let me write it as input, and Q is my output, right? So let me write this as my output. So students, we are very much familiar to write the inputs and outputs. So let us end this inputs. I mean the declaration of inputs and outputs. Okay. So here the next is architecture behavioral, right? Architecture behavioral of test JK I can give as, let me declare the signals. Okay. So I'm declaring the signals. So let me begin the process. So to begin the process, we know that clock and reset plays an important role, right? So let me begin, because without the clock and reset, our process will not happen. So next, let us come to the conditions. If reset is equal to 1, then our output is equal to 0. So here the output I am indicating as S. Else if clock event and clock is equal to 1, then. So students, when I say clock event and clock is equal to 1, we know that, clock event is either the rising edge or the falling edge, correct? So this clock event is very important for a flip-flop to work. Okay, so considering here the rising edge here, that is why I say clock event and clock is equal to 1, then, okay, so what happens? Let us begin the process. So I shall write our conditions over here. If j is equal to 0 and k is equal to 0, so this is our first case, then our output is assigned to the present state, right? Our output is equal to the present state, correct? So else if, let's go to the next condition, when j is equal to 0 and k is equal to 1, then, so what happens? We know that our output is equal to 0, correct? So here it is like this, okay? Then else if, students, what is the next condition? When j is equal to 1 and k is equal to 0, then s is equal to 1, correct? Else if, let us check for the last condition, when j is equal to 1 and k is equal to 1, then s is equal to not of s. Right, students? So we have almost written the conditions, the 4 conditions, correct? So once we are completed with the conditions, so what else we have to do? We have to end the process. So this end if is to end the else statement. This end if I am writing here is to end the process which we have begun, and this end if, yes, there will be only 2 end if, correct? And Q, the output, is equal to S. That is, we have already declared the signals. So signal is assigned to the final value. That is what is Q is equal to our output S. So finally, it is our end process. Okay. So dear students, I hope you would have understood the concept. So basically, using our truth table of the JK flip-flop, we have checked for the inputs, assigned the inputs and outputs in the port, and we have declared the signal, and we have begun the process with the clock and the reset. Without the clock and the reset, the process will not start. Then we have implied, or we have replicated all our inputs, right? The conditions, when j is 0 and k is 0, when j is 0 and k is 1, when j is 1 and k is 0, and when j is 1 and k is 1, right? So in all these 4 cases, we have indicated what happens to our output, and we have ended our cases. Dear students, hope you have understood the Vhdl code for JK flip-flop. For any doubts, you can revert back to me. Thank you.